In this video we are looking at area of figures, and in this video we're looking at converting a triangle to a triangle of equal area, just putting a small twist in it. We're going to convert a quadrilateral to a triangle of equal area, and we're also going to convert a five-sided shape into a triangle of equal area. So this is the setup of the page. We've got a scalene triangle, two quadrilaterals here, and then a five-sided figure here also. So in a previous video we were looking at drawing a triangle as another triangle of equal area, and to do that we need to look at the formula, and the formula for a triangle, the area of a triangle, is half times the base times the perpendicular height. So this is the base, perpendicular height would be a line from here down to the same level as BC, so that would be the perpendicular height. Multiply all of that by a half. What I want to look at in today's this setup is if this is the base, let's say AB is the base rather than BC, how does that change things? Well, to be honest, it doesn't. It changes how we look at it, but it doesn't change what we're going to do. So if this is the base, the line from A to C, I'm just going to extend the line B down this way. This would be our perpendicular height. So this distance here is the perpendicular height. So I can find another triangle equal in area to the one ABC here by taking a line parallel to C, or parallel to the line AB from C, and that keeps the perpendicular height the same. So if I were to put the point, put the apex now at this point, so now triangle ABD has the same area as ABC. It has the same base and it has the same perpendicular height. That's just something we'll be looking out for and we will be using later on. So now we're going to look at the second piece, and that is a quadrilateral, and we're going to convert this into a triangle of equal area. And now we're going to use something to do with what we did over here. So I haven't dealt with a quadrilateral before, I've only ever dealt with triangles. So is there something that I can do to this to turn this into triangles so to make it a little bit easier? So what I'm going to do is I'm going to extend the line BC, and just to get a setup, but I'm going to convert this into triangles, and I convert it into two triangles. I can join B to D and get a triangle here, or I can join A to C, which is what I'm going to do, and that's going to give me also two triangles. So I'll have a triangle ABC and triangle ADC. So one triangle here, second triangle up here. So what I can do now is I have one triangle and I have a second triangle. But if I try to get rid of this, that's what I'm going to do. I'm trying to convert this now into a different triangle of equal area. So what I'm going to do is, if we ignore the bottom half of this first, we have a triangle ACD. So I'm going to convert that into another triangle, but this time with point D down here on the ground. If I was to do that, A would join to this point down here on the ground, to B back to A. So I'd get one large triangle. So if I'm going to take AC as the base of this triangle, just like AB was the base of the triangle over here, I'm going to draw a line parallel to that from D and the reason I'm drawing a parallel line is that it keeps the perpendicular height of that triangle the same. So the perpendicular height is always perpendicular to the base of the triangle. So this height here is the same as the height is over here. Just like it was when I took the base of the height over, or the perpendicular height here, it's the exact same on this one. So parallel to this until it touches off the ground line, so on a line extending from B through C. that gives me a new point, so I can join A to that point, A to X, back through BC, and back to AB. So I now have a triangle ABX that is equal in area to the quadrilateral ABCD. So the area of this part here, that's outside it, is equal to the area of this bit of it off over here. How this works is we're using our principle that half the base, or half times the base times the height, perpendicular height, is going to give us a triangle of equal area, one triangle, and this is a second triangle of equal area as they both have the same perpendicular height off the line AC. Just going to do that again down on this one. You can join B to D or A to C, that's up to you. A joining down to C. I'm going to parallel to that line from D. So if I was to pick a point here, join that back to A and C, that would give me a triangle equal in area to ADC. So it's be the same. What I'm going to do is I'm going to extend the line BC on, giving me this point down here, we'll call it X, joining A to X, and that gives me a triangle ABX that is equal in area to the quadrilateral ABCD. So for the final one that we're looking at today, we're going to look at this here, which is a 5-sided shape, and I want to convert that into a 3-sided shape, so into a triangle. To do that, we need to work our way from a 5-sided shape to a 4-sided shape to a 3-sided shape. So we're going to use what we've looked at here and work that backwards. If you had an 8-sided shape, you would still be working back. You'd go 8 to 7 to 6 to 5 to 4 to 3, working your way back that way. So I have this irregular pentagon. I have my 5 vertices A, B, C, D. And what I'm going to do is I need to divide this up into something that I know how to work with, which are triangles. So I'm going to keep CD as the base. So I'm going to take A to D. That's one triangle, and A to C here as a second triangle. So this looks, I now have one triangle here in the center, second triangle off to the left, and third triangle off to the right. What I'm going to do is I'm going to convert these different areas. So I'm going to take it first from 5 sides to 4 sides. To do that, I'm going to do like what I did up here. So I'm going to ignore this half of it. I'm going to focus on this bit off out here to the side, which is the same as what we did up here. So I'm going to take a line parallel to the line AD from point E, and everywhere along this line now, I could draw a triangle that is equal in area to the triangle ADE, because it has the same base, AD, and the same perpendicular height, because the lines are parallel to each other. So line CD running along here, I'm going to extend that line now. So extending the line CD till it intersects that blue line coming from E, and that gives me a line from A down to X, back in to C. So I now have a quadrilateral A, B, C, X, back up to A, that is equal in area to the 5-sided figure that we had a moment ago. So A, C, X is equal in area to A, C, D, E, A. that part of it there. What I'm going to do now is I'm going to take this 4-sided shape into a 3-sided shape. So again, this time we're operating on this triangle. So I'm going to take a line parallel to the line AC from point B. So if I pick a point here and join that to C into A, I'll get a triangle that is equal in area to ABC. It has the same base AC and it has the same perpendicular height. So measured perpendicular from the base, that height stays the same the whole way across. So our formula stays the same. So again, if I extend the line DC out until it intersects the green line, that gives me a point on the green line that I can draw a triangle equal in area. So we'll call it Y. So A to Y to C. So AYC is the same area as ABC. Now this pink area here, AYX, is a triangle equal in area to the pentagon that we looked at earlier. So this area here, the pink area, is equal in area to the pentagon that we had earlier on, A, B, C, D, E, back up to A, equal in area to A, Y, X.